So, as we begin discussing polynomials, we're going to start with quadratics. First thing we're going to talk about with quadratics is the general form. This is what the quadratics look like. And this is the key piece right here, because without this squared, this would no longer be a quadratic. If it was gone, we'd be dealing with a linear function, not a quadratic function. The first thing we're going to look at is that leading coefficient, that number that's in the front. If that number is positive, this quadratic points up. If it's negative, it's going to point down. And again, the squared is what makes it a quadratic. So they're easy to kind of see if they were a U-shape going up or a U-shape going down based on that leading coefficient. Some of the characteristics we talk about with quadratics, we talk about its domain. Okay, one way we discuss this is by saying all reals, or we might say from negative infinity to positive infinity. That means I can plug in any x value I want. It's going to work. The range depends on whether this thing is pointing up, so I stop at 0, or if it's pointing down and I start at 0 and I go in the negative direction. So if it's pointing up, it starts at 0 and goes to infinity, so it's greater than or equal to 0. If it points down, I start at negative infinity and I stop at 0. That means y is less than or equal to 0. Now, the other thing that we have to keep in mind is if the vertex is moved. I've been talking about a vertex being at 0, 0, but if we move that vertex, this point would also change. The range would also change, even though the domain won't change. So let's talk a little bit about the vertex. Here's how we get the x-coordinate out of this general form. We're going to do the opposite of b divided by 2a. That would give me the x-coordinate. This is where the maximum or minimum value occurs, depending if it's pointing down, which is a minimum, pointing up, which is a minimum, or pointing down, which has a maximum. Once we have that x value, we can plug it back into the function to get the y value. This is what the maximum or minimum value is. So when we look at that point, x tells me where it occurs, y tells me what the maximum or minimum value actually is. So let's do an example of this one. Here I have my function, and I'm going to label my a and my b and my c to make it a little easier to see. And according to this, I'm supposed to do the opposite of b over 2 times a. And that's supposed to tell me where this maximum or minimum occurs. So I end up getting negative 12 over negative 6, which is 2. There's my x-coordinate. Now I'm going to take my x-coordinate and plug it back into the function to get my y. So I'm going to go negative 3x squared, 12 times x, minus 8. So I have some arithmetic to do. 2 squared is 4, 4 times negative 3, 12 times 2, and then minus an 8. So when I put these things all together, I get y is 4. So that tells me the maximum occurs at 2, and the maximum value is 4. Now if I take what I talked about over here when it comes to the range pointing up, pointing down, that leading coefficient tells me this is pointing down. So this is actually a maximum. The other way we tend to see quadratics is we have them written in standard form. This is a little different. Notice that the a is still there. It's still going to tell me if it's up or down. But now we have this h and this k. Sometimes standard form is referred to as vertex form because the vertex is easy to spot. It is the h and the k. Notice that the h changes signs when it comes out of there. It's in parentheses, so it's backwards. The k comes from the outside. This is the vertex. So here's my function example again. Notice it's still pointing down, so it has a maximum. And the maximum occurs at 2, 4. This example that I did is the same example from up here, Down here it's written in standard form. Up here it's written in general form. Either way, we're dealing with a quadratic that points down that has a maximum at 2, 4. The other thing you may see is you may see them asking about increasing or decreasing. So if I do a quick sketch of this graph, the maximum is at 2, 4, so it's up here. This graph is increasing until it gets to the maximum. Then it begins to decrease after the maximum. If I had one pointing the other way, it does just the opposite. It decreases until it gets to the minimum, and then it increases after that.